Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 3, 2025, just yesterday. This paper introduces a new framework that more than triples agent performance on complex search tasks, jumping from about 14% accuracy to over 42% on the GAA benchmark. The paper is titled, Decoupled Planning and Execution, a Hierarchical Reasoning Framework for Deep Search. And this approach could really change how we build agents for difficult problems. The authors argue that single models are inefficient for complex search, so their framework separates high-level planning from detailed execution. Also, the authors shared their implementation on GitHub. And it's not just the code. They've included detailed setup instructions and the scripts you'll need to run experiments and evaluate the results. It's a pretty comprehensive resource for anyone wanting to try out the HiRA framework for themselves. Alright, so this first figure really visualizes the core idea. On the left, you see current methods, like direct reasoning, which is just a straight line of thought, and search augmented reasoning, where a model can pause to use a tool. But on the right, you see the new hierarchical reasoning framework. It's completely different. A central planner breaks down the problem, and coordinators assign these smaller tasks to specialized expert agents. These experts, like a search-enhanced agent, do their own focused work, and then their findings are summarized and sent back up. This process is called reasoning distillation. Building on that idea, this figure gives us a more detailed look at the architecture. At the top, you have the meta-reasoning planner, which handles the high-level strategy. In the middle, the adaptive reasoning coordinator acts like a project manager, delegating tasks and performing that reasoning distillation we just mentioned, which is basically summarizing the expert's work. It also uses a dual-channel memory, a shared knowledge base with facts and resources, to keep all the agents in sync. And at the bottom, the domain-specialized executors do the heavy lifting, using their specific tools. Okay, so now we get to the numbers. This table lays out the performance across 4 different benchmarks, which are basically standardized tests for these AI agents. The key one to look at is GAIA, a really tough test for general AI assistants. The new hierarchical reasoning framework, listed at the bottom, achieves an average accuracy of 42.5%. Now, compare that to the next best search-focused agent, WebThinker, which only gets about 13.9%. That's a massive leap, and it really shows that this multi-agent, hierarchical approach pays off dramatically. So to really prove that every part of their system matters, the authors ran what are called ablation studies, where they systematically remove one component at a time to see how performance is affected. This table shows those results, and the impact is huge. Look at what happens when they remove the specialized search agent. The average score plummets from nearly 45% down to about 14%. Likewise, removing the coordinator's reasoning transferability, which is how it smartly delegates tasks, also causes a major drop. This really proves the whole hierarchical design is essential. Drilling down a bit deeper, this chart breaks down that strong GAA performance into 3 specific skill areas. We see reasoning and web browsing, multimodality capability, and file understanding. And in every single category, the new framework, shown in the red bar, comes out on top. The biggest gap is in multimodality, which is the ability to process different kinds of information, like text and images, together. Here, the framework scores over 33%, which is double the next best method. This result really shows the power of using specialized agents for distinct tasks. So, when you pull all these results together, the takeaway is really clear. Current methods, like retrieval augmented generation, which is where a model pulls in outside info to answer a question, often struggle with complex tasks because they use a single model for everything. This research shows that by decoupling planning from execution, using a hierarchy of a planner, a coordinator, and specialized agents, you can achieve dramatically better and more efficient results. It's a powerful new blueprint for building more capable AI assistants. That's all the time we have for this week's AI Research Roundup. Thanks for tuning in.